Hi everybody, this is Mark Clayton with Restore Cars again with another action-packed episode of cutting and welding and drilling. Today we've got a 1932 Stutz DV32 dual overhead cam straight 8 engine that we're going to be cutting all the main bearings on. All we're going to do to this block is do the main bearings. This is for another restoration shop, which we do a lot of work, particularly engine machine work for a lot of the restoration shops. So it's another one of these 9 main bearing crankshafts, so there's a lot to do here. Unfortunately, that's all we'll get to see on this build, but it'll be interesting to see how we go through this process. Let's get started. Well, the first order of business is to get the thing chained up and picked up by our overhead crane. Sure makes easy work of it when you've got those overhead cranes and electric winches. I'm measuring here for some holes that I can mount some studs in there, and that's what's going to tie the block to our parallels on the line boring machine. So then we just slide her on down the rail and get ready to drop it into the line boring machine. Sure makes easy work of it, boy, with that electric winch. And we put a hand winch on it too, so I can just very carefully lower the thing down in my exact position that I want. We're gonna go make an adjustment here. We're gonna go in that groove right there. Because we want this thing pretty much centered on our parallels, centered on the machine. Go. Now we'll get that guy in position right there. Then we'll get this guy in position and we'll lower it down just like that. So the next thing we have to do is we have to put a bar in here. We don't want to move this, but we want to move this so it lines up with this. And about there. That gets us in the ballpark. Put this bar on the other side and rough it in. I didn't have the right size pucks to line up the bar in the block, so I'm just going to make my own. We take some 7000 series aluminum, chuck it up in the lathe, and the trick here is that the center bore has got to be in the exact middle of the outside bore, because that's what's going to line up our crank and the crankshaft. So careful machining here is a must. We make sure that we get everything precisely in the right spot. This is really imperative. I can't stress this enough. This step has to be done absolutely correctly. Otherwise, if your crank isn't centered up in the bore, it's going to be a bad day for everybody concerned. So I take my time, make sure my measurements are right on the money, and then I part them off. And I like a nice wide puck because it's going to stay nice and straight when we set it in the saddle. So make 2 of these, set them up in the number 1 and number 9 saddles, and we're ready to go. We put the boring bar arms on each side of the main bearing on each end, number 1 and number 9, and we keep adjusting it until it goes right through the middle. My usual shop didn't do the babbitt pouring on these shells. Another shop did, and they were provided for me. So I had to drill out all the oil holes, and I had to do the milling in the caps for the oil to travel back and forth, especially in number 1 and number 9. So that's easy enough to do on the mill. Most all your bearing have a number on both the cap and the shell. So that's good, but they're not always marked like this. So I make sure that I have everything marked right next to each other so that when I take the engine back apart, I get it back together exactly the way that I line bored it. So I always take a number stamp, and this is 5, so I'm going to stamp the bearing right next to the 5. This way I make sure that when I take this apart and this bearing is floating around, that I come back and I see my 5, and there it is. Make sure it goes back in the right position every time. Okay, the next step that we're going to do is we've lined up all of our caps with the inserts in them, all double check to make sure in the right direction. And so what we're going to do is we're just going to start installing these into the saddles here. Just like that. Then we'll put the washers on and the nuts. And another thing is, I always count this stuff out and I make sure that I've got the right amount of hardware laying here. I always know where my hardware is and how much I've got laid out. Okay, next is torquing these things down. In this case, it's going to be 75 foot-pounds. We'll just go down the line. Okay, the next thing we need to do, we need to mic all the main bearings on this crankshaft and check to see how close they are. They always vary a tenth or two, but we want to make sure that we're not like a half a thou off. The first thing I do is I always check my mic against the standard and make sure that it's right on. We keep our shop at 72 degrees all the time, and so we keep everything acclimated to the same temperature. When you're doing your rod bearings and you're doing inserts in that, it's important that you're on the same page as your crank grinder, because he'll be in one location and you'll be in another. Now, like on all of our line bore jobs, we start out with the first bearing with my red mic, because I'm going to get the final size with this mic. So we've set our tool so it's the inside diameter of this bearing right now, and we just set this mic to what this tool is telling us right now. Just like that. Just make sure this is seated on the bar and the end of our mic is touching our tool. We have about 90 thousandths to cut out of this rough bearing here. So my first cut, after I set my tool to this, which is the inside of this as it is right now, I'll go ahead and move this tool out 50 thousandths and we'll hog a bunch of it out of there. So I'm on 35 now. I just go all the way around to 35 again. Then pull my tool out, take my mic, put it right on the tip of the tool, give it a little back and forth, make sure the apex is hit, set that tool, move it up to my bearing down here, and now I'm ready to make my first cut. Go down the line and cut them all to size and do the chamfering, and it's all just the same procedure, with our final mic being our red one. Now for the moment of truth. Does it spin? Well, I cheated. I already did it, so I know that it spins around just fine, especially with this lever in here. The real way you can tell great crank work, great bearing work is if you take 9 main bearing crank, it'll just spin like this. You know, you got all these bearings that are causing friction. By the time you get all these things torqued down, well, you got quite a bit of friction. But if you could just take your hands and spin it like that, it works really good. Here's what I cut these to. The rule of thumb is for each inch in diameter of your crankshaft journal, it's 1 thou. This is a 2.5 inch crank journal, so 2.5. But I try to go between 2 and 2.5. All these stabbed right on that number, so it's right on the money, except for the rear main here, and I like to cut those at 1.5. And that's what a lot of the books call for. So I'm right on the money on this one too, and I've got everything just really nice and spins nice. It's not going to drag horsepower. It's going to have good oil pressure, so this is going to be a great job, and thanks to the wonderful machinists at Stutz when they made this incredible motor. That's it for this engine. We're on to other engines in here. I counted no less than 16 engines in the engine shop the other day, so we've got a lot of engines to bring to you here on the YouTube channel, and we've got 15 cars under restoration. So perhaps we'll put together an episode on walking through the shop, and I'll show you what all is going on. Till then, thanks, take care.